Hi, we are discussing certain concepts from linear algebra and their relationship to machine learning. In this part, we'll be talking about the concept of vectors and the vector space. Okay, so you guys are already aware of most of these concepts, but we need to review for the sake of the advanced content of machine learning. Okay. First, we need to clarify the concept of scalars. For example, a person's height, okay? So a person's height, 1.72 meter, okay? Some other scalars are something like weight, salary, okay? And we want to actually define a person, okay, through certain scalars, okay? For example, their height, weight, and salary, and we put it in these third brackets, and then we remove their units, okay? No explicit mentions about units, okay? So this becomes a vector definition representing a person, okay? And this is how we actually encoding every person, and here we have a list of person, okay, or a group of people, okay. You can think it as rows in a table, and the first column being their height, second being their weight, and then third being their salary, okay. So this is actually the vectorized representation of people. You can think it as the content of a table or a matrix, okay. This row, in this case, we call it a vector, and then the entire table content, we can think it as the content of a matrix, okay. In mathematics, the vector is actually an ordered n tuple, okay. So what do we mean by that? So if we decide that the first value of a vector would be the height of a person, second the weight of that person, and third being their salary, then we have to always follow that format, okay. So this is a row vector, but we can also order these numbers in a column, okay. So this is a column vector, okay. So you can think it as this as a row in a table, so row vector, and this is a column of a table, is a column vector, okay. We can apply some mathematical rules, okay. So that's the thing that we learned in high school, and it is applicable also here, okay. So you can do some additions. What is zero vector? All the values are zero, okay. The coordinate center, okay. This is the dot product that we have used in the cosine distance. You will do element-wise multiplication and do the summation, okay. So this is what we call inner product or dot product, okay. I show you some example. You can do some practice if you're not clear, okay. When two vectors are called orthogonal, when their dot product is zero, okay. For example, here you have 4, 0 and 0, 2. If you do their dot product, so element wise 4 times 0 is 0 and 0 times 2 is 0, and then you sum, the value is 0, okay. So this actually confirms that these two vectors are orthogonal, okay. The norm, okay. So if you recall, in our cosine distance, we had the norm at the denominator. So it is actually the dot product with itself, and then you take the square root, okay. So for example, here 4, 3 is a vector. So we have 4 times 4 and 3 times 3, and then sum, and then take the square root. That becomes 5, okay. You can do some practice of your own, okay. So it was quick. Here we are explaining how do we define a vector and how to do some operations on those vectors, okay. So if you are clear, now you know how to estimate the cosine distance, because you know how to do the dot product and how to also do the norm calculations, okay. So this is how we are estimating the cosine distance. So you have to do the dot product between P1 and P2, and then you have to divide by the product of these two individual vector norms. Okay. If you are unclear about anything, feel free to ask me questions. Okay. Thank you.